In my previous video, I explained linear and non-linear forms of adsorption, isotherm and kinetics. In part 2, I would like to talk on various types of errors used in adsorption, isotherm and kinetic study. So this video is very important and please do not skip it. Well, the most commonly used error analysis is Rsquare or coefficient of determination, which is a statistical measure to qualify the linear regression, and it is defined as R² equal to this, and it is a percentage of response variable variation that explained by the fitted regression analysis, and it has got value between 0 and 1. If the value of R is 0, which means that the fitted line explains none of the variability of the response data around its mean. On the other hand, if R² is 1, it suggests that the fitted line explains all the variability of the response data around its mean. However, the larger the R² value, the better the fitted line of adsorption data. Secondly, adjusted R² value. It is a modification of R² value which is adjusted for the number of predictor in the fitted line. It can be also used to compare with the fitted lines with different numbers of predictors. If the number of predictors is greater than 1, then adjusted R² is always smaller than 1. Then comes root mean square of error, which is equal to the square root of reduced chi-square, and the equation of this error can be written as this. Then comes non-linear chi-square, which is very important in the determination of the best fit of adsorption analysis. And the equation of chi-square test is given as this. Now, if chi-square is equal to the residual sum of square divided by the degree of freedom, the value of chi-square close to 1 indicates that it is a good fit and implies that difference between observed data and fitted data is consistent with the error variance. Let us talk about coefficient of non-determination. It is very important tool for describing the extent of relationship between the transformed experimental data and the predicted isotherms and minimization of error distribution. And it can be given as Cn equal to 1 minus R², where R² is the coefficient of determination. Then comes Zsquare test. This test is calculated by taking an observed number divided by it by the predicted number, then taking the natural log of this ratio. And it is also known as a log likelihood test or a likelihood ratio test. and the equation is given by Zsquare equal to this. Then comes Pearson's R, which can help to measure the strength of linear relationship between paired data, and its value could be -1 to +1. And it has been suggested that in linear regression analysis, a positive value suggests that there is positive linear correlation between predictor variable x and response variable y. On the other hand, a negative value suggests that there is negative linear correlation between predictor variable and response variable y. Sometimes it can also come zero value, which means that there is no linear correlation between data. However, it should be remembered that the closer the value is to -1 and +1, the stronger the linear correlation is. Now, residual sum of square RSS or sum square of errors, and this is most widely used error function, and it is the sum of the square of vertical deviations from each data point to the fitting regression line. It can be inferred that the data is perfectly fit if RSS equal to 0. However, it can also help to decide whether the fitted regression line is a good fit or not. The smaller the residual sum of square, the better the model fits. Then comes hybrid fractional error function. It was developed by Kapoor and Young to improve the fit of the sum square of errors at low concentrations by dividing it by the measured value. This function includes the number of data points minus the number of parameters or isothermic equation as a divisor, and the equation is written as this. Then comes average relative error, was developed by Marquardt with the aim of minimizing the fractional error distribution across the entire concentration range, and the equation is given by this. Then comes sum of absolute errors. This model is similar to the sum square error function, and in this case, isotherm parameters determined using this error function would provide a better fit as the forward high concentration data, and the equation is written as this. Then comes Marquardt's percent standard deviation, which is similar to a geometric mean error distribution modified according to the degree of freedom of the system, and it is given by the equation. Then sum of the normalized error. Well, a standard procedure known as sum of normalized errors is performed to normalize and combine error in order to make a meaningful comparison between parameter sets. Standard procedure is selection of an isotherm model and error function and determination of adjustable parameters which minimize the error function. Then determination of all other error functions by referring to the parameter set. Then computation of other parameter sets associated with their error function, and normalization and selection of maximum parameter sets with respect to the largest error measurements. And finally, summation of all these normalized errors. These are the references from which most of the information have been collected, and in my next video I will show you how to perform error analysis for isotherm study using origin. Then I will explain how to do error analysis for kinetic study. Thanks for watching.